Alright, this is the last page. This is going to be quite a bit of a doozy, so we'll see if we can get through it. So number 17, we finished 16 in the previous problem. The first term of an arithmetic sequence is u of 1 equals 5, and the common difference is d equals 2.5. Find u of 2 and u of 3. So first off, they tell me it is a sequence, and they're telling me directly, hey, we're using the u values. So I'm going to use my u formula. U of n equals u of 1 plus n minus 1 times your common difference. They also tell you u of 1. They tell me u of 1 is 5, so I can start plugging in values. And they tell me my common difference is 2.5. And to find u of 2 and u of 3, you are just going to plug in those values for n. Plus so you'll notice all I did was using my original function with the u of 1 plugged in and my common difference plugged in. U of 2 just means, hey, plug in 2 for n, because instead of u of n, I have u of 2. And then for u of 3, it just means, hey, plug in that for n. So, to get that, 2 minus 1 is 1. 1 times 2.5 is 2.5. 5 plus 2.5 is 7.5. So we have 7.5. And then, for u of 3, you have 3 minus 1 is 2. 2 times 2.5 is 5. 5 plus 5 is 10. So u of 2 is 7.5, u of 3 is 10. Write down the general term u of n of this sequence. All this is saying is, hey, write down the formula. You didn't need the formula to find u of 2 and u of 3. You know the common difference is 2.5, so you know you're always increasing from 2.5, so you could have just done 5 plus 2.5, which is 7.5, and 5, or 7.5 plus 2.5, which is 10. So you don't need the formula to find 2 and 3. Now, you do need the formula for part C, which is find the smallest value of n, for which u of n is greater than 377. So we want u of n to be greater than 377. And I have a u of n formula, so I can plug it in. 5 plus n minus 1 times 2.5, and I want that to be greater than 377. In this case, I can solve it algebraically, so I can subtract 5 from both sides, divide by 2.5, and add 1. I can also do nsolve. So, menu, 1, and I'm going to say 5 plus, parentheses, n minus 1, parentheses. My common difference is 2.5. Instead of putting greater than, I'm going to put equal, comma, n. If you do this, you get 149.8. But you have to be careful. We cannot have a 100 or 149.8 term. Your terms have to be positive whole numbers or positive integers. So, if we want to be greater than 377, we can't do 149. 149 will be a little bit below, so we have to round up. So it has to be 150th term. So be very, very careful with that one. So n equals 150. Because it has to be the whole number. It has to ends, because it's like first place, second place. You don't have 2.5th place. It has to be positive integers, so round. And that is 17. 18, consider the arithmetic series. Remember, sequence are the lists. Series are where you add them together. So usually represented by capital S, and sequences are usually represented by the U. 20 plus 20.4 plus 20.8, so on and so forth. Find the number of terms in this series. find the value of s. So for number 18, I can write a formula. Hopefully you can find your common difference. You can notice it's increasing by 0.4 each time. We know my first term, 20, and lucky for us, we know our last term. We know u of n. Now, u of n is just a general term. The u of n is not always the last term. However, u of n is the term that we're talking about. In this case, since they want us to find the total number of terms in this series, so find the number of terms in the series, u of n is 37 because it's going to be the last term, so it's all my terms. What I don't know is n. I don't know how many terms there are for me to get to 37.6. So, first off, I can, if I want to find the number of terms in this series, use my u of n formula. So let's, I guess, write it down here. U of n equals u of 1 plus n minus 1 times my common difference. I know u of n is 37.6. U of 1 I know is 20 plus n minus 1 times my common difference of 0.4. I can use nsolve to find n to figure out how many terms I have in my sequence. So let us do that. I don't suggest getting too used to nsolve. It's good to know how to algebraically solve it. So to go, SADMAP. Oh, whoops, not linsolve. nsolve. 37.6 equals 20 plus n minus 1 times my common difference is 0.4. Solve for n. 45. There are 45 terms in this sequence. So now I know n. I figured out how many terms are in the sequence. That is part A for number 18. Now I have to find the value of s, which means s is the sum of all my terms. So my s of n formula is s of n equals n over 2, 2 times u of 1 plus n minus 1 times d. Or the other one, n over 2, 2u of 1 plus u of n, which is the shorter formula. In this case, I know u of n. I know the final value. So I can use a shorter formula. S of n, and in this case, I know n. I just solved it, which is 45. S of 45 equals 45 over 2 times u of 1. Let me make sure I have the right formula. Okay, the shorter formula is just u of 1 plus u of n. So I know u of 1. U of 1 is 20. That's the first term in my sequence, or my series right here. And I know u of n. U of n is what I'm looking for in this case, my last sequence, or my last term in my sequence. And then you just solve. 45 divided by 2 times 20 plus 37. So 45 divided by 2 times 20 plus 37. Excuse me. 1,296. So that is my sum. So that's your S of n. Number 19 is another one where it's an arithmetic sequence. Write down an expression for S of n, the sum of the first n terms of the arithmetic sequence. 105 plus 100 plus 95. So we want to find just a general equation for this one. Now I'm going to erase all of this right here so I have more space to do number 19. So if you need to copy it down, just go back to the previous, just rewind, basically. Okay, so number 19, write down the expression for S of n. Now we have two formulas. Notice how it doesn't give me the final term. That means I'm most likely going to use a longer formula. Always leave n as a general term because it's just a general formula, but we know u of I is my first term, or u of 1, my bad, which is 105, plus n minus 1. I know my common difference because I can look at it. Notice it goes from 105 to 100, 95. It is decreasing by 5, so my common difference is negative 5. And that is my general formula. Hence, find the value of n for which S of n is 1140. So, I need to solve for n. So I can plug this into my calculator. You can also simplify if you want. So for example, before putting in my calculator, I can simplify 2 times 105. But let me put this in my calculator. So menu, 31, 1140, equals, control divide, n over 2 times 2 times 105 plus n minus 1 in parentheses times negative 5 solve for n. 19. It takes 19 terms for me to get to that sum of 1140. And that's it. That's part 19. A few more questions to go. Question 20, consider the sequence of the figure, figure 1, figure 2, figure 3. Figure 1 contains 3 line segments. Find the number of line segments in figure 7. So first off, we know u of 1. They just told us u of 1 is 3. We need to find common difference. So notice I go from 3, and then from my 3, I'm adding, let me try to make it more neater, 1 line segment, 2 line segments. So now I have 5. 1, 2, 3, 4, 5. And then, this is part of my original, I'm adding 2 more line segments. So my common difference is 2. You're always adding 2. So you have 1, 2, 3. You have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So you're always increasing by 2. So if we want to figure out the 7th, or the line segments in the 7th figure, I can use my u of n. Now it's not asking for a total. It's just asking how many lines does the 7th one have individually. I'm going to use my u of n formula. And I want to find the 7th one. I know u of 1 is 3. 7 minus 1, because I want the 7th term. And I know my common difference is 2. I just solve it. 3 plus 7 minus 1 is 6. 6 times 2 is 12. My 7th figure will have 15 line segments. So all I did was 7 minus 1, which is 6. 6 times 2 is 12. 3 plus 12 is 15. Part B says, given the figure n contains 251 lines, show that n equals 125. For this one, you cannot use nsolve because you have to prove it. So let me erase this from the last one. And you need to use your general formula. So they give us the end result. And remember, when it says show that or prove that, you plug in both values. And so I'm going to plug in 3 plus this 125 for n. For my common difference is still 2. So once again, you cannot use nsolve. You have to show it by hand that this is true. So 3 plus 125 minus 1 is 124 times 2. 124 times 2 is 248. 248 plus 3 is 251, which gives you a true statement. That's how you show that. So if it says show that, you have to show it by hand. A lot of times the show that's are pretty simple. It just means plug in both values. So in this case, the 251 line is my output, and the n equals 125 is my input, is that n value. Part C, find the total number of line segments in the first 100 figures. Since this one says total, I'm going to use my S of n formula. So anytime you see the word total, you know you're using this one. Now I don't know the final term in my sequence, so I have to use the longer version. Now, they tell me the first 100 figures, so that is my n value. I already know u of 1 is still the same problem, so it's still the 3. Once again, I know n because it's my 100th term I want to figure out. And I know my common difference because I'm increasing by 2. So my u of 1 and d are still the same from original. And from here, you just solve it. You do not have to use nsolve this one. You can just work through either by plugging the entire thing into your calculator, everything after the equal sign, or just solving it by hand. So let's put this into the calculator. That might be faster. 50 plus, or 50 times 6 plus 99 times 2. 10,200. So 10,200. All I did was kind of shorten it. You could have put the entire thing into your calculator without the S of 100. You only use nsolve when you're going backwards and you have to solve for n. But if you already know n, then you can just plug it in. So all I did was 2 times 3 is 6. 100 minus 1 is 99. 2. You'll have 6 plus 99 times 2. 9 times 2 is 18. 9 times 2 is 18. Is 198. Which makes sense. 198 plus 6 is 204. 204 times 50 is 10,200. Or 10,200. Ta-da! You're done with 20. 21. A sequence is given by a of n equals negative 10n plus 3. Show that the sequence is arithmetic. So remember, for a sequence to be arithmetic, it has to have a common difference. And the common difference has to be either added or subtracted. It cannot be multiplied. So they're telling you, okay, here is your general sequence. A of n equals negative 10n plus 3. To show that it's arithmetic, you want to show that there's a common difference. So if I put in the first few values, so for example, a of 1 is negative 10 times 1 plus 3. That's going to give you negative 10 plus 3, which is negative 7. A of 2 is going to be negative 10 times 2 plus 3. which is negative 20 plus 3, which is negative 17. A of 3 is going to be negative 30 plus 3, which is negative 27. You're showing that there is a common difference where you're subtracting 10 each time. Which you can kind of tell here. You can tell that your starting point is 3 and that you are always in, or you have a constant rate of change of negative 10. But you just want to show that, hey, look, when I list them out, it does show that there's a common difference of negative 10. Find the smallest k for which a of 1, or a of k, that's really small as c, is less than 1,000, negative 1,000. So let me give myself space. So you want to find the smallest k for a of k, so we're using this formula, is less than this. So my general formula is a of n equals negative 10n plus 3, but we want to show that a of k is less than negative 1,000. So the formula I'm going to use is negative 10k plus 3 less than negative 1,000. This one you can solve algebraic. You really don't need to use n solve for this. You can just subtract 3 from both sides. You will get, oh, this is actually really important. This will get you negative 1,003, because you have to subtract 3 from both sides. Really, really, really important. When we are solving this, I'm going to divide by negative 10 on both sides. Anytime you divide an inequality by a negative, you flip the inequality symbol. We haven't really seen that in any examples. It rarely shows up, but it is a tiny rule to know. And by doing nsolve, it won't show you that. It's not really important because you just have to follow it as well as k. So you really just have to find the number, but that is something good to mention. And I don't know why I accidentally wrote 2 negatives. Negative 100.30. Now, once again, for your k value, you have to have integers, so you would probably just round this one. 22, Debbie borrows 1,800 pounds and wants to pay it back over 3 years. She has 2 options. Option 1, pay simple interest of R%, or option 2, pay interest as a flat rate of 18% of the borrowed amount. So to determine how much interest Debbie would have paid if she chose option 2. So for option 2, it's just a flat rate of 18% of her borrowed amount. So you want to figure out what is 18% of her borrowed amount. So you'll do 0.18 times her borrowed amount is 1,800. And that gives you 324. So she is going to pay 324 pounds. There we go. Part B. Find the value of R that makes Debbie pay back the same amount for either option. So for part B, where you have to find the same amount, anytime you have to find the same amount or a time at which they're equal, they're looking for intersection points. So your equation you basically want to figure out, okay, she's paying a flat rate for option 2 of just 324 pounds of interest, no matter what. That's what a flat rate means. So no matter how many years, she just paid that much. what you have to figure out is, okay, how long does it take for the first option, or what rate of interest will make it so that she's also paying the same amount of interest back for this. So we don't know R. R is unknown. And it's simple interest, so we know our simple interest formula's interest is capital times my rate times the number of periods. My interest I want to pay back is the 324. So we want to figure out what rate will give me that. My capital or my principal or my starting amount is still the 1800. You don't know R, that's what you want to solve for. You want to figure out what rate will make this true. And she wants to pay it back over 3 years. So, times 3. And then we just solve it. So you'll do 1800 times 3, which is 5,400. I did an extra 0. Whoops. There you go. Times R equals 324. We'll divide by 5,400 on both sides. Four divided by 5,400. My interest is going to be 0.06%, or 6%. So remember, you can turn decimals into percentages by moving the decimal place over 2. So for her to pay the same amount of interest in 3 years with the same amount of principal or the same amount of capital, it has to be an interest rate of 6%. Last problem, problem 23. Transfers from the airport to a passenger's house have different prices. Here is a table with some journey lengths in kilometers and their respective prices. Plot a graph on this data on your GDC. If you don't remember how to do this, let's see. Here's my GDC. I'm going to go to spreadsheets. This is going to be my, let's say, X list. And this is going to be my, let's say, Y list. And in my table I have, for my X's, 10, 25, 36. And on my Y list I have 450, 810, and 1200. To plot this on my GDC, I'm going to go to Menu, Stats, that's calculate, oops. Well, that was the same, what I had to press anyways. Stats, Stats Calculations, and you want a linear regression. And you want to use your X list for your Y list. And you're going to save your regression to f of 1. Okay. So you have your MB value. If you go to your graph and you go up, you'll see this. So here is your line. Choose an appropriate model for the price of this journey. I chose a linear regression model. You can always tell, it's probably been a while since you've done this, or actually you might not have done it, depends on your class. Let me go back to my spreadsheet. And this was my 1.2 spreadsheet. R squared. R squared value basically tells you how well your model matches the data points. So how accurate your model is, more or less. The closer it is to 1, the more accurate your model is. The farther away from 1, the less accurate your model is. Notice this is 0.98. It is very, very close to my model, so my model is a pretty good model. So it's most likely a linear regression model. If it was For example, 0.8 or 0.6, that probably means my table was probably representing maybe a quadratic function, an exponential function. But since it's so close to 1, it probably means, hey, you do have a linear regression model. Here we go. We found the equation for the model, which is here. M is 28.5, B is 144. Use your model to estimate the prices of the journey when the passenger lives 27 kilometers away from the airport and 40 kilometers away from the airport. So, to figure out these, we go back to my calculator, I go back to my graph. My graph is right here. I want to copy the function and calculate. So I want to figure out how far I am when I'm 27 kilometers away. So instead of using x, I'm going to use 27. I'm this far away. And then instead of 27, they also want to figure out when I am 40 kilometers away. That's my answers. And that is your review. These are a lot of videos. They probably took a while. Let's see. So, if you have any questions, stop by at tutoring. Your test will be on Monday. So either send me a remind message, email me, look at the answer key, rewatch the videos, or just let me know if you have any questions. Feel free to stop by for tutoring.